Hello, in this video we're going to look at how I've managed to add some drag and drop functionality for my inventory. So this is specifically where I'm able to drag an item from one slot and then drop it onto a different slot in order to effectively move its position, right? So I've covered several posts on how to build the inventory widget. So this is covered in these links over here. And in this one specifically, we're going to be looking at how to effectively handle that drag and drop functionality. So we will be looking at sort of a high-level overview of all of the widgets that I used. And then you'll see that towards the bottom of it, there'll be these drag and drop events for the actual slot widgets, right? So you'll see them covered over here too. So as usual, all the steps can be found on this post, so do check that out. And I'm also using this with the Java server, and that's available on GitHub as well. So both of these links will be available in the description. So let's just quickly start with a demo so you can see what it is that we're building, and then we can sort of jump into the code as well. Okay, so for the demo, what I'll do is I'll log into one of these characters that I've prepared earlier, and I've already added a couple of items for us to work with. So what I'm now able to do is click on one of these items and essentially drop it to a different slot. So each time I'm dragging this and dropping it into a different slot, I'm sending a request to the server to move that item. So that's what's happening there. So I'm also able to drag it onto a different slot which already has an item, and it will actually swap their positions out as well. So later on I'm going to add functionality to drop it onto different equip slots as well, so I haven't done that yet. At the moment I'll just double click them to unequip these items. So again, the equipping and unequipping was actually handled in a different post, so you can find that in the links below. But yeah, in this one, we're specifically looking at how we can drag items from one slot and another. And this implementation is very similar to the ones that we've done on skill bar. So you can actually use the same sort of techniques for different widgets as well, right? So that's what we'll be looking at, but again, with the context of the inventory. All right, so let's get started. Okay, so perhaps we'll begin with the inventory component. So this is an actor component, and I'm going to put most of the logic to handle the inventory inside this actor component. So I want it to be driven through the actor component rather than the widget, right? And this is mainly because I've got this parent class connected component base, which I've created to handle the communications with the server. So I want all of that logic to sit in one place, which is why I've created this inventory component to deal with those requests. So if I open up my player base v2, so this is the parent class for my player character blueprint, you'll see that I reference this inventory component. So that's how it gets loaded, and that's how we effectively call our event begin play. So when I load my character, it's going to load up this component, and then it's going to call this event begin play. Okay, so when I load up my component, one of the first things that I want to do is link it to the widgets. So when the widgets get created, my actor hasn't actually been spawned yet, so you can control which one gets spawned first. And in my case, my widgets get spawned before my actor. So what I'm going to do is simply load up, or rather find the widgets. So you can see get all widgets of class. And in this case, I'm looking for the inventory panel. And when I found it, I'm going to call this function that I've created to link to player inventory. And the main thing that I want to reference here is that I'm simply promoting it to a variable. This is mainly because whenever I have interactions with the inventory, the actual functionality will come from the component rather than the widget class, right? The widget is sort of an interface. When you click a button, it asks the inventory component to sort of deal with that request. But I've also got a couple of bind events here, so we're going to cover those shortly. But essentially, the inventory component will have several functions exposed. Whenever they get called, I want to send out an event which the widgets will be listening to, and then they'll sort of display relevant information whenever those get called. Like I say, we'll cover those shortly, and it will probably make more sense. So I've got several of these link functions. So one is for the inventory panel, the other one is for the equipped item slots, and then another one is for the equipped item widget. So these two are kind of out of scope for this video. Those are for the equipped items, but we can probably cover them sometime in the future. So let's look at what else we have in this function. Okay, so after linking my component to the widgets, the next thing that I'm going to do is fetch the inventory from the server, fetch the equipped items, and then register the inputs. So for fetching the inventory, this is a simple request to my server. You can see the update type is just requesting to fetch inventory, and I just need to provide the actor ID. It's basically the same thing for fetching equipped items. I give the actor ID and I just ask to fetch the equipped items. For register inputs, this is basically the mapping context for inventory actions. So for example, when I click I want to open the inventory. If I click it again, I close it. So it's that kind of stuff. There's a couple of others for picking up items, for example, as well. So that's what we do when we begin play on the inventory component. Okay, so next what we can do is see what happens when we get some of the responses. So for example, we've just seen that we've requested to get the inventory. So I'm also going to receive an update from the server with the inventory update. So it's going to go ahead and call this function. So let's see what happens when we get this message. Okay, so when I receive the message to process my inventory update, I'm going to get the entire state of the inventory. So this will give me, the size of my inventory, how much gold it has, what the character items are, and things like that. So this is actually one of the points I'm going to try and optimize in the future so that it gives me sort of these incremental updates rather than the entire state. But this is the state of it right now. I get the entire state of the inventory. And what I'm going to do is actually I'm going to process and extract the size of the inventory and then pass that to the widget. I'm also going to extract the character items that are inside the inventory, and I'm going to pass those independently as well. So before we go into those functions, let's have a look at the contents of the inventory. Okay, so the inventory structure contains the character name, the character items, the gold, and the max size. So the max size is used to then draw up all of the inventory slots that we have inside the inventory. So it's like a 2D array, right? So for example, 2 by 2 will have, 2 rows and 2 columns. The gold, I'm not actually using that right now, but it will just represent how much gold the character has. And then the character items, this is represented through this character item structure. This again contains the actor ID, mainly because in the database they're stored independently. It has the item instance and then the location of where that item belongs to. So the item instance effectively contains the instance ID. This is to avoid item duplication and things like that. And then the item ID, this is the actual item, right? So for example, a sword can have an ID of 1000, whereas your item instance ID, this is a unique identifier for that particular instance. The item structure itself, this will have things like your item name, the category, the value, etc. So that's how my inventory is set up. And now we can go back to the inventory component and see what else we have here. Okay, so when I receive this message, then the first thing that I'm going to do is process the inventory size. And as you saw earlier, we've got the max size part of the inventory. So if I go back here, there it is, the max size. So it just gives me a sort of 2 points, right? The rows and the columns that we need to draw for the inventory slots. So one small optimization that I've done here is I'm only going to be calling this dispatcher to update the inventory max size if it's changed, right? Because I'm going to be constantly getting inventory updates. I don't want to be sort of needlessly sending this function to update inventory max size if it hasn't changed. So you can see here, I just check, is the max size different to its previous state? If it's different, I'm going to update the local variable, and then I'm going to call the dispatcher, and the dispatcher is basically set here with update inventory max size. So you can see it over here. So it just has this location 2D as one of the inputs, and this is essentially one of the functions that we bound to, and we'll look at that after we explored the second function as well, which is the process changed inventory slots. Okay, so let's go inside this function. So at the moment, it doesn't do too much. So what we're going to do is we extract the character items from the inventory update. At this point, this is an array. And what we want to do is then convert it to a map where the key is the location. So this location is used to identify the slot that this item belongs to. So it's much easier for me to convert this array to a map at this stage and then simply call the dispatcher with these updated items, which is basically this variable type with a location 2D against the character item itself. So the character item will contain references of the item and the location references essentially the location of the slot. So now we can have a look at these bind effects, how we actually bound to them and how we process them. Okay, so we don't actually call the update inventory gold dispatcher yet, so I'm just going to ignore that for now. So the two that we've looked at is the update inventory max size and the update inventory items. So let's check this one out first because this is a prerequisite for updating the items. So basically when we call this dispatcher, we're going to execute this function, which is update max inventory slots. So that's this function over here. So let's see what happens. Okay, so this function might look a bit complicated, but it's actually relatively straightforward. What we have is this inventory size, which is a like number of rows and number of columns. And we basically want to iterate over each entry. So this is a nested for loop. So you can see here, we've got this for loop. We begin with index 0, and we're going to go until rows -1. We promote it to a local variable. Here I've just got a basic implementation of do this, and when you finish doing that, add 1 to the current row, and then this will iterate it again until the last index, and then we repeat that for columns, right? So at this point, we now have an implementation for each row and each column, and this does look a lot simpler on a encode essentially, right? So the blueprints simply inflate this, but it's relatively straightforward logically speaking, right? So for each entry of row and column, do this. And what we do here is basically create a new inventory slot widget, which is basically this little slot which goes inside the inventory panel. So this is the inventory panel. The main thing here is the scroll box, and inside there is the grid panel. And this is a uniform grid panel. So what it means is that I'm able to specify the row and the column for where this child component goes into. So this becomes really useful. One thing to note is that I've got this location. So this location means that I'm able to locate the inventory slot quickly. And specifically the way I do that is through this variable. So when I added this component inside the uniform grid, I'm also keeping a reference of it over here. So you can see if I click item slots, this is a map where the key is this location 2D structure. So it tells me the specific location of where that slot is. And then the value is the slot reference, right? So next time when I get an update for a character item, I know where to find that slot. So that's the point of this variable over here. Okay, so in this character item structure, this is a map of location 2D, which is the key, to the value of the character item. So the first thing that we're going to do is extract all of the keys. So this is all of the locations for the items, and we iterate across them. So I'm going to promote it to a local variable just to make it easier to access. And we'll look into this set that I've created. So present item location. So this is a set of these location 2D structures. This will be relevant on the completed part. So we'll cover that shortly, basically. One of the first things that I want to do is make sure that the processing locations is valid. So when I equip an item, this location becomes -1, -1. So it's still part of the inventory, but I don't want to display it essentially, right? So I just have this little filtering logic over here. So once I've done that, I go into the actual processing part. So I'm going to want to find the character item that I'm processing. So this character items, this is the same variable as from the input of the function. And we use the processing location to get that item, right? So from there, we get the item instance. And I've actually covered this in a different video, so I won't go into too much details there. But basically, I construct an object to represent an item, and this object has information like, the icon to draw inside the inventory. That's the main thing that I need right now. So I'm also able to find the slot widget really quickly because, again, the key is the processing location, and we just covered that in the update max inventory slots. So you can see that the processing location is the key on both the character items and the item slots, and that's really what makes it quite quick for us to look those items up. And so if it exists in this map, then I'm going to go ahead and execute this update slot functionality. So I've actually added this bit of logic. So this is particularly for when I'm going to refactor the inventory. So if I'm going to send it slots independent, or rather the inventory size independently from the items, I may get the items before I get the max size. So I've just got this retry mechanism. But you might not need this. Like I've never called this yet, so this is just in case at the moment. And then the update slot, this is on the actual slot widget. So this is about updating the icon information. So this is documented more in the blog post. So if you're interested, you can check it there. Okay, so now we can go back to the inventory panel, and this sort of completes the flow for the items which are present in our inventory. And the next thing that we're going to need to do is clear out slots for where we don't have items. So as an example, let's say you had an item in slot 1-1, and let's say you deleted it or dropped it. It's no longer going to appear in your character items, but you still need to clear that slot out, right? This is why we kept this set of present item locations, because this basically tells us which slots we should not be clearing. So on completed, what we're going to do is iterate over all of the item slots, right, except for the ones in this set, right? So for example, if this array element is contained in here, do nothing. And if it's not there, then we need to update the slot with a null item object, so effectively clearing that slot out. Okay, so that generally completes the flow of how we update the inventory. So again, these events come from the inventory component. Our inventory panel binds to those events and then processes the update max inventory slots, which then creates those slots. And then also update inventory items, which populates those slots with items. So then the next thing that we can have a look at is the implementation for the inventory slot itself. And this is the one that's going to have the drag and drop functionality embedded in it. So let's have a quick look into the update slot as well. So this is the one that we've referenced earlier. I want to just highlight that one quick optimization that I've done here is that if the item object is the same as the local parameter, it's not going to do anything. If it's different, it's going to promote it to the local parameter and update the icon. So the icon that's been updated, what you can see is just setting brush from texture. It gets it from this item object, which is covered in a different video. And it basically just populates this item icon in this image. Okay, so while we are on the designer view, it's worth going over a couple of things. So for drag and drop functionality, you're going to need a root component which is going to be able to register the on-drop event. So this is, for example, your panel components. So for example, the canvas panel, the I think grid panel should work too. And the border component size box, these ones should work for capturing the on-drop event. Now, the other thing that you'll have to do is set the visibility to visible. So if it's on any of these other ones, it's not going to be capturing those events. One thing that I've noticed through my testing is when I had other components nested inside of the border or your other components, if they were also visible, it could sometimes hinder with the on-drop effect, and sometimes it just didn't work as well. So what I've actually done is disable this visibility on the button. So I did actually want to use the button for the click events and things like that, but its performance just wasn't as good for me, and we'll cover them shortly. So what I've done instead is set the visibility to non-hit, and I've also disabled the children, right? So it has some limitations. So for example, in my case, you can see when I hovered over this button, it would change its image. So that will no longer work. But again, I sort of prioritize the usability. So the on drop will perform better, which is why I've disabled it. Okay, so let's now go back onto the graph view, and there's a couple of functions that I've overridden here. So basically, this widget component, you can click override, and so you're not going to be able to see them now, but there's going to be on drag detected, on drop, and then on mouse button down, and on mouse button double click functions available here. So those are the ones that I'm going to override, and we'll implement the functionalities here. So when I detect mouse button down, the first thing that I really want it to do is start detecting whether there's any drag, right? So when you click, if you're dragging your mouse down, this function will start detecting that, right? So this is directly linked to on drag detected. So unless you start detecting that drag, it's not going to get called into this function, right? So don't forget to add that in. And the other thing that I've done here is I just check whether or not I have an item present inside this widget, right? So if my slot doesn't contain an item, I don't want it to do any sort of drag and drop operations. So the next thing that I do, if my item object is valid, is create the drag and drop operation. So it's the default function that you can find over here. So you can see I didn't override it, so I didn't provide it a different class. This is something that I've done before, but I thought, you know, the default drag and drop operation is actually sufficient for this. So you can see all I needed to define is a couple of parameters for me to actually process this request. So the first thing that I did was specify the tag. So you can see in the tag description, it says a simple string tag you can optionally use to provide extra metadata. So that's exactly what I'm doing here. I'm saying that this drag and drop operation refers to an item drag and drop. The payload that I'm providing is the item object, which I've just validated is not null. In terms of the default drag visuals, I simply referenced this drag image, so you can see it's a variable, so I simply provided that as the default drag visual, and that's actually enough for my drag and drop operation. This will create the default drag visual, and now the next thing that we have to do is implement on drop. Okay, so let's look inside here. So on drop, we're going to get a reference of this operation that we've just created. So I'm just going to put it into a variable, and I'm going to check the tag. So at the moment, I only have the one tag that I want to process. So it's a tag for item, right? So you saw this referenced over here, right? So inside this tag. And if it's equal to item, I'm going to go ahead and execute this function, which is handle item placed. And from the operation, I simply want to extract the payload. The payload contains the item object that I'm processing. And from there, I'm going to be executing this move item, which is going to be processed by my Java server. So in order to process the move item request, I need the item instance ID. So this refers to the item that's being moved, and I'm providing it the location. So I'm going to also add the functionality to move it onto an equipped slot, in which case I'm going to need to provide the category. All right, so for example, a weapon, a glove, or a helm, whatever it may be. So at the moment I don't support that, but I will soon. And in this case, like I say, I'm moving item found by item instance ID to this location. So if we look inside this request, I'm using the server connector. So this is inside the inventory component right now. I'm using the server connector to send the WebSocket message, and the message is to move item from this item instance ID to this location, right? So let's have a quick look into the Java server for the move item implementation. So it basically bubbles down to this function, which is to move item. So you can see I've got the actor ID, item instance ID, and then the location moving it to. So what I'm basically doing is getting the item found by instance ID. I'm getting item at location, so this is moving to location. If this item exists, the two locations are going to swap between each other. Otherwise, simply get the item and set its location to the updated one. After I've updated the inventory in the repository, I return the entire inventory, and this loops us right back to some of the functionality that we saw earlier, which is updating the inventory items, which is how you're going to see the entire inventory update itself, right? Because I provided the full state of the inventory. Okay, so perhaps we'll look at the last function here, which is the on mouse button double click. And basically, I just want to remind again that all of these functions which are on override, they are affecting the entire widget, right? So basically, it'll just mean that it'll register to the root component here. And again, let's make sure that the visibility is set to visible. So that's how it will make sure that they're enabled. And if I double click anywhere on this widget, on this root widget, it will mean that it will trigger this effect, right? So what I'm going to do is I'm going to equip an item when I double click, and you'll see that I've tried several different methods here. So for example, I've registered the on click event on the button. So this is where I had a variable for monitoring the button pressed. I also added an event listener on the item icon. So this is an image component. Not sure if you can see that there, but it says on mouse button down. So it's basically connected to this function here. So I wanted to handle the item click event as well as detect drag if pressed. So I tried several different ways. It just didn't perform as well, particularly on the on drop listeners. So it just was a bit flaky, right? It would work 80% of the times, and sometimes it just didn't register that on drop event. So that's why I ultimately settled to disable the child components, essentially without visibility, and instead I applied the listeners on the border component, right? So when I click, when I double click it, I'm going to execute this function from the inventory component, right? So to equip item using socket. And again, this is just a request to the server to equip the item, right? And when the server processes that request, it will again just send me the state of the inventory. And once again, it will just go through all of that flow again, refreshing all of the slots on the inventory. Okay, so perhaps we'll finish off with a quick demo again, and I'm going to try and reference the functions that we've looked at in this video. So when I spawn my character, it has the inventory component associated to it, so therefore we get called on event begin play of the inventory component. So inside this function, we're going to register ourselves to the widget components, right? So the first one is this equipped items, and then the other one is the inventory panel. So the inventory panel contains the uniform grid, and this is where we're going to be creating our slots. So again, part of the constructor, or this event begin play, after registering with these widgets, we also fetch the inventory. So when we receive that response from the server, we're going to start processing it, and the first thing that we're going to do is start creating these slots. So this is processing the max size of the inventory, which is effectively, you know, your rows and columns. So in my case, it's an 8x8 inventory. So if you count this as like 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 rows and 8 columns. And it's using a nested for loop to basically iterate over each one and create those slots. So I also reference these slots in a map array, a map variable, where the key is going to be the location and the value is going to be the slot widget itself. and this allows me to quickly locate that slot whenever I need to update it, right? So then the next thing I do is process the inventory items, which again have the location of that item referenced, so that when I try and add it onto those slots, I use that variable to quickly locate that slot and update it. Now I can talk about the actual slot implementations themselves. So there's a couple of events registered on them. So the first one is on click handler or on mouse pressed handler. I start detecting drag, and when I'm moving my mouse, that's when the drag operation starts being implemented, and it's going to do a couple of things. So the first one is it checks to see whether there's an item associated to that slot. If there is, it's going to allow me this drag operation. The next thing is that it attaches the item object inside that drag operation, and it also provides the image, so the image associated to the slot, as the drag visual. So that's what you can see as I'm dragging this object around. Then I also have the on drop handler. So each one of these slots also has the on drop effect, which basically consumes that drag operation, and it takes the payload, and then it uses that payload to send a request to the server to move that item. When the server processes that move request, it then just sends back the entire state of the inventory back to my character, and it's going to refresh all of these items. Okay, so that's the basic rundown of all of the inventory that I have so far. Perhaps the next thing that I'm going to do is add the functionality to drop items to my equipped slots, right? So at the moment I have to double click them, so you can see that being added there. So perhaps I'll just add the functionality to drop these items onto these as well. But that's it for this one. Thanks, and see you next time. Bye.